today we will see how to create quick explosion in Houdini. As you can see on my screen, I have created this in Houdini under less than 10 minutes. So I have this explosion and I have created some wedges as well. So all these are done procedurally and the simulation is also very fast. The setup is also easy. We just need two outside node which was developed by a guy called Cpos Atilia. So we need his spiky source HDA and one more HDA called pyro source volume. I will give this link in the description. So let's dive into Houdini and see how to create that explosion. So first let's take a geo node and take an add node. So here we will add one point and then we will use HDA called spiky source. So it will look like this on creation. So first thing we need to do is we need to turn on this create points from volume and we have to go in points and reduce the point particle size. So this much is enough. We don't need lots of particle here. Scale the velocity to 90 and increase the seed value to 7. Although you can change this parameter and create different type of explosion, like I have set a wedge parameter for the seed only and I get this type of different variations. Now here on the direction, let's adjust this little bit on the X. So here we will keep it to 0.6 and here we will keep it to 0.1 and let's reduce this a little bit to 1.8. so it will look like this. Now we have to decrease the spread parameter by negative 0.2 and here on the control range of the noise value we will increase it to 1.4. so we will have more velocity on the bottom of the area and here we will decrease it to 0.9. okay, now you can go on the attribute noise and we have to turn on this attraction weight since we will use this as a vellum grains and here the max value will be 1.68. You can set this first slider to the initial of the ramp and this one to the end, and we need also some velocity noise, so you can see it will have a little bit difference. We have to turn on this length as well. Now you can simply take a vellum solver and connect it here and here increase the substeps to 10. Let's add a ground plane since our plane is colliding with the source. We will bring it little bit down by, let's keep it to negative 0.5. go on the forces tab and add wind in the X direction with the value of 3. So let's play this and see how this looks. So you can see we don't have chunks of this particle since we have here attraction weight attribute, but we are not getting chunks here. To get that chunks we need to go in the advanced tab, go in the grain collision and we have to increase this attraction weight value to 1. Now if I play this, you can see we have a chunks here. Let's play this and see. So you can see after it's getting down on the ground, the chunks are still sliding on the ground. To fix this, we can go on the forces tab and increase the static threshold to 10 and dynamic scale to 1. This will add friction to the particles. Now you can see our grains are not sliding. The next process is we can take a vellum post process node and then you can cache this out. So I will take a file cache node here and let's name it vellum grains. I will save it to disk. I need only 100 frames, not more than that. So I will cache it to disk. So it will look like this. Yeah, cool. Now we need to take pyro source volume. So I will go in the cp pyro source volume. Here you can see we have to set a few things here. So here we need density, temperature, divergence force and velocity. And here on the basic, turn on this arrest and we have to set the mode to set and the rest frame will be first frame hour. Now we have to, as you can see here, we have a few particles below the ground, so we will remove that particles. Now we have to turn on aging. So aging will set the age attribute on these particles. So our start frame will be 10 and the end frame will be 30. We don't have to change this. And now we have to turn on noise. So if we turn off this, then the whole particle will have almost the same kind of age. If we turn on noise, then it will set some offset to it. Now we can turn on enable remap ramp and we will keep this value as well default only. Now we have particles only, but we need trails for the better pyro simulation. So we will click on this trail node, trail parameter, and you can see we have a trails here. But the problem is the trails are fully straight. We need to add some noise, so we will click on this drop down arrow and we will click on trail noise. So we will have here trail noise. So let's reduce the increase the noise parameter by 0.11. Cool. Now we can go in the attribute and here on the noise location we will choose rest. Now go on the density tab and here on the max value we will keep it to 1.5 and here on the element size let's keep it to 0.5. Now go in the temperature, let's keep it to 1.56, sorry, 1.6. And on the element size let's keep it to 0.2. Cool. Now we are all set. So this will be our trails and on the second output we will get the volume source. So I will make the background as dark so we will have a better preview, but the resolution is too low, so let's increase the resolution. So I will reduce the division size to 0.5 and the particle scale to 0.45. I will also turn on the normalized clamp coverage. Now we are all set. You can see. Now we have to take the pyro solver. So since we have to simulate explosion, we have to set up our sourcing first. So let's go in the source tab, and we have 4 volumes: density, divergence, temperature, and velocity. So on explosion, we don't need density volume too much, because the smoke will get emit from the flame source. So here on the density source, reduce the source scale to 0.1, and for the temperature we will not use the pull operation, which is set by default on the solver. We will use the add operation, and we will increase the source scale to 3. And on the flame, you see there is a source volume as burn, but we don't have a burn sourcing. So here, instead of burn, we will use our density only, but this density will go on the flame, which is our target field. So the flame source scale will be 2. Now on the velocity, here we will use the pull method. So we will choose the operation as pull, and the source scale will be 5. The acceleration strength will be 50, and the deceleration will be 1 only, and the direction strength we will set it to 15. Now we have to add one more source, and this will be our divergence field. So on the source volume we will choose divergence, on the target field also we will choose divergence, and on the operation we have to choose pull. Now our source scale will be 10, acceleration strength will be 50, and deceleration will be 0. Now if we will play this, it will look something like this. So right now also we have our very basics explosion kind of thing. As you can see, we have divergence going on here, the expansion of the flame, are everything happening, but it is not proper. So let's set up all the things. So the main thing in explosion is our time scale. On the initial frame, the time scale will be quite big value, and it will reduce gradually between 10 to 15 frames. So here we will write fit function, and here we have to use float frame, not the integer. If you write $f, then it will consider it as a frame, integer frame. If you write ff, it will consider as a float frame. So here our first frame will be 1, and our last frame will be 16, and our max time scale will be 1.75, and in the end we will keep it to 1.25. So now if I turn the simulation off, you can see on the initial it will be 1.75, then it will slowly get reduced to 1.25. Now here on the advection reflection we have to choose single project. Now we have to go in the bound, and on the resizing tab, since we don't have flame, we don't have a flame source, we will use temperature here, and we have to go in the collision tab now, and here on the ground plane we have to choose this Y ground plane, and here we have to select close below, so that our bounding box will not go below the grid. Now we have to go in the field tab. Here on the dissipation, reduce the value to 0.05, and we have to turn on this use control field, and we have to turn on this remap field also. And here instead of going 0 to 1, we have to invert this. So select this one and set the value to 1 on the for the last one. We'll make it to 0. Now here we have to turn on this emit from flame, and here we will choose the operation method to add, and we have to turn on this remap flame range. Now go on the temperature tab. Here we have to reduce the cooling rate to 0.1, and we have to also turn on this speed field so that it will calculate the speed field based on the velocity. Now we have to go in the shape tab, and here in the Beyonce tab we have to write this code here, the same code here which we have wrote. I will copy this, go in the field shape, and I will go in the shape tab and I will paste it here. Instead of 16 I will choose 11 here, and the maximum value will be 3 and the lowest value will be 0.1. We have to reduce this reference temperature as well, which will be 2000. This, so on here we don't have to change anything. Now go on the disturbance tab, and the disturbance value will be extremely high, like 35. Now we have to expand this. Here on the density threshold range we will keep it to 0.01, and we have to turn on this use control field so that the default will be speed field. We don't have to change this. Now here we will keep the minimum value to 0.1 and the maximum will be 5. Now let's play this and see how this look right now. In this also we don't have expansion too much, so let's do the few things more. So we have to turn on this turbulence, and here we have to choose analytic simplex noise, and here also we will paste the same code, fit range code, and instead of 16 we will keep the frame to 11, and the maximum turbulence value will be 10 and the minimum will be 0.1. The swirl size we have to increase is to 15. Let's increase the pulse length to 2 and the max octave to 3. Here on the threshold range we will keep it to 0.1, and rest of the thing will be default. Now here we have to turn on this shredding, and let's expand this. Let's keep the shredding value to 5, and here we just need to change the max octave to 3, and the rest of the thing will be default. And make sure to increase this threshold range to maximum value to 3. Now the main thing is this flame expansion. Let's turn on this and expand this. Here on the flame range the minimum value will be 1 and the maximum will be 3. Now let's play this and see how this will look. So you can see now we have the flame expansion here, and then it's getting converted to smoke. Now we need to increase the minimum and maximum substeps. First let's go on the sparse solve, and here on the reset rule we have to choose Here we have to choose newly occupied or deoccupied. So here we will choose only velocity and temperature. Now we have to go in the setup tab and let's increase the minimum and maximum sub steps and also increase our resolution. Let's set the voxel size to 0.08. Now let's play this and see how this look. So now let's take a pyro bake volume, and here on the smoke let's keep the density scale to 5, and here we will use a ramp, and the density range will be 1 and the maximum will be 2, and here we will make it little bit more. Yeah, something like this. Yeah, now we have to go on the scatter and turn on this scatter. Let's reduce the intensity scale to 100, and here we will use the source range will be from 0.5 to 2, and we have to turn on this blur. We have to turn on this use blur steps, and we have to increase this to 3, and filter voxel radius to 5. And here for the masking we will animate this. So from 2 hell we'll keep it to 1, and then it will decrease it to 0.1, 0.1. Now we have to go on the fire tab, fire, and let's increase this value to 5 to 75, and the source range will be 0.0001, and the maximum will be 12.6. so it will look something like this. Now here we have to increase the source range from 0.1, and we need to also turn on the masking, and here we will keep the value to 0.4, and the rest of the thing are default only. We have to turn on this max ramp as well. Now we have to go on the binding tab. Since we have here we have density, temperature, flame, but instead of using temperature as the intensity volume, we will use flame here, which will be more accurate. As you can see, here we have better details on the flame source. Now we have to go in the output, and we have to turn on convert it to VDB, so that we will have VDB here instead of volume, which takes too much of the space. So our last part is we have to go inside the solver, and we have to add gas turbulence. Here on the time scale we will copy this time scale and paste that in the here, paste relative reference, and here we will choose analytics simplex noise. Source scale will be 1, swirl scale will be 5, pulse length will be 1, and the seed will be 6. We have to increase the turbulence to 3. Now go in the control setting. Here instead of density we will use temperature. Control influence will be 1, and the control minimum 6, 3 and 6. Now let's play this. Cool. Now if we want some different kind of explosion, then we can go on the spiky source, change this seed parameter. Let's turn off this gas, and if we go on the bake volume, then we will have different explosion here. Now if I go on here and set it to 10, let's set the cache. Cool. So let's cache this out.